Hey guys, Mr. Backenberg here. In this video, we're going to look at linear programming. So as we're doing linear programming, we're going to be doing something called optimization, meaning that we're going to look to maximize or minimize a certain value. And what we're going to be working with is a linear function, which we're going to call our objective function, and we're going to look at maximizing or minimizing that objective function over a set of points that we're going to find by using a system of linear inequalities. And we're going to call that system of linear inequalities our constraints. Now, as we're looking at our system of inequalities, there's going to be overlap between all of our different constraints, all of our different inequalities, and we're going to call that region our feasible points for the optimization problem. And that set of feasible points is going to be our feasible region for the problem, meaning that that's kind of our potential answers for the problem. If our linear programming problem, if our optimization problem is going to have a solution, it's going to occur at one of the vertex points or corner points on the boundaries of our feasible region. So what we're going to be looking at are these different inequalities, and those vertex points, those corner points, are going to be the intersections between our different lines that we're working with. So here in this first example, we're going to look at finding the maximum and minimum values of our objective function f, which is 5x plus 8y, and we're given these four constraints down below. So the first one, we've got 2x plus y is less than or equal to 10. Our second one, we've got 2x plus 3y is less than or equal to 14. X has to be greater than or equal to 0, and y has to be greater than or equal to 0. So what I'm going to start off doing is graphing out all of these different inequalities. As we look at this first one, to make that one easier to graph out, we're going to want to get that in sort of like a y equals form. So I'm going to subtract that 2x over to the right-hand side. So this is going to say y is less than or equal to negative 2x plus 10. Now to graph this out, we're going to pretend there's an equal sign in there, and then this will look like a y equals mx plus b equation. The b value is 10, meaning that our y-intercept is up at 10. And then we've got a slope of negative 2. So I'm going to go down 2 over 1. And I'm going to do that a few times to give myself a good idea of what this line is going to look like. And then I'm going to go ahead and draw in my line. Now, because this inequality has the equals to line underneath it, it will be a solid line. Now, because this is a less than inequality, we should do some shading, but I'm going to hold off on that for now because we've got these four inequalities to graph out, and what we're going to be looking at is the overlap between all of these. So I'm just going to wait till the end to do my shading and just look at where all of these are overlapping each other. For my next inequality, I want to get my y alone, so I'm going to start by subtracting that 2x over to the right-hand side. So I would have 3y is less than or equal to negative 2x plus 14, but then I'm going to divide everything by 3, so y is less than or equal to negative 2/3 x plus 14/3. Now this looks sort of like a y equals mx plus b equation with a b value of 14/3, so that's going to be 4 2/3, so just a little bit less than 5. And then we've got a slope of negative 2/3, so we're going to go down 2 spaces and over 3 spaces, down 2 spaces and over 3 spaces, and I'm going to draw in my line there. Now for this next one, x is greater than or equal to 0. Remember, an x equals line is a vertical line through that x value. So we're going to have a vertical line through the x value of 0. For our y is greater than or equal to 0, that's going to be a flat horizontal line through that y value of 0. Now, based on all of these inequalities, I said I was going to hold off on the shading until the end because we were going to focus on the overlap between all of them. This first one that we drew out in red, that's a less than inequality, so we would shade below the red line. This green one is a less than inequality, so we would shade below the green line. For our x is greater than or equal to 0, we would shade to the right of our blue line. And for this y is greater than or equal to 0, we would shade above our purple line. So the overlap between all of those is this little region in the middle here, which I'm shading in pink right now. So that's our feasible region. Now earlier on we said if our linear programming problem is going to have an answer, it's going to happen at one of the vertex points. So we want to identify the intersection points between all of these lines that we just drew out. So the first intersection point that I'm seeing is right here at the origin. So one of the possible solutions is the point 0, 0. We've got another intersection point happening over here on the right-hand side, the intersection between our purple and our red lines there. That's the point 5, 0. The intersection between our red line and our green line right in here is the point 4, 2. And the intersection between our blue line and our green line is the ordered pair 0 and 14 thirds. So as we're looking at a maximum or minimum value here, those are going to happen at one of these points. Now to figure out what our solutions are going to be, we're going to look at our objective function, that f equals 5x plus 8y, and we're going to take each of these ordered pairs and we're going to plug them in. So let's look at plugging in 0, 0 first. So we would get f equals 5 times 0 plus 8 times 0. So 5 times 0 is 0, 8 times 0 is 0, so we get an answer of 0. Then I'm going to plug in my 5, 0 point. So it's going to be f equals 5 times 5 plus 8 times 0. Well, 5 times 5 is 25, plus 0 is 25. Then I'm going to plug in my 4, 2 point. So f equals 5 times 4 plus 8 times 2. 5 times 4 is 20, 8 times 2 is 16. Add those together, we get 36. And then lastly, we need to plug in our 0 and 14 thirds point. So we're going to get f equals 5 times 0 plus 8 times 14 thirds. Now 5 times 0 is 0. 8 times 14 thirds is going to give us a decimal answer in there. So I would probably just type that into my calculator. And we should end up getting about 37.3 repeating, so 37 and 1/3. Now we were asked to find two things. We were asked to find a minimum and a maximum. Out of these answers that we're seeing here, we can see that 0 is the smallest value, so that's our minimum value. And we can see that this 37.3 is our biggest value, so that's our maximum. So the minimum occurs at the point 0, 0, and the maximum occurs at the point 0 and 14 thirds. Now in this example, we're dealing with a word problem, so we're not just given the equations and the constraints. We have to try to figure them out based on the context of the problem. So Sanger's Produce is purchasing some fertilizer looking for two specific nutrients, nitrogen and phosphorus. They need at least 180 units of nitrogen and at least 90 units of phosphorus. Now their supplier sells two different brands. Brand A costs $10 a bag and has 4 units of nitrogen and 1 unit of phosphorus, and brand B costs $5 a bag, and that has 1 unit of nitrogen and 1 unit of phosphorus. Now Sanger's can only pay at most $800, and what we're going to try to do is minimize our cost so that we're paying as little as possible for the proper amount of nutrients. Now we've got two different brands in here, so we should define our variable. So I'm going to use X to represent the bags for brand A, and I'm going to use Y to represent the bags for brand B. Now we're looking at minimizing our cost, so that's actually going to be our objective function. So I'm going to use C equals, C for cost. For brand A, that costs $10 a bag, so it would be 10 times the X amount of bags that we buy, plus brand B costs $5 a bag, and we used Y for brand B. So this is our objective function that we're trying to optimize. We're trying to minimize that cost in there. Now the first thing that we're told is that we need at least 180 units of nitrogen. Well, if we look at brand A gives us 4 units of nitrogen. So I'm going to go 4 times X in there. If we look at brand B, that gives us 1 unit of nitrogen, so I'm just going to do 1Y. So when we add up the total amount of the nitrogen, we need that to be at least 180 units, so greater than or equal to 180. Now, as we're looking at our phosphorus, we need at least 90 units of phosphorus. So brand A has 1 unit of phosphorus, so that's 1x, plus brand B also has 1 unit of phosphorus, so that's 1y, and we said at least 90, so greater than or equal to 90. Now, we also know that we need our cost to be somewhere under $800, and if we're paying $10 for brand A and $5 for brand B, then that inequality is going to look like $10 for brand A plus $5 for brand B needs to be less than or equal to that $800. Now, there's going to be a couple of other constraints in here that won't be as important, but we are going to need to buy at least 1 bag of each brand. So our X needs to be greater than or equal to 0. We need to buy more than 0 bags of brand A, and our Y needs to be greater than or equal to 0 because we're going to need more than 0 bags of brand B. Now, in order to graph these out, we're going to need to get these inequalities in sort of like a y equals mx plus b. So for this first one, I'm going to subtract that 4x over to the right-hand side. So this is going to say y is greater than or equal to negative 4x plus 180. For my second inequality here, I'm going to subtract that x over to the right-hand side. So y is greater than or equal to negative x plus 90. And for this last one down here, I'm going to start by subtracting the 10x over to the right-hand side. So we're going to get 5y is less than or equal to negative 10x plus 800. Now, if I divide that 5 over to the right-hand side, I'm going to get y is less than or equal to negative 2x plus 160. Now, what I'm actually going to do is I'm going to take these 3 inequalities that we've got right here, and I'm going to graph them out on my calculator so that I can find their intersection points. Now, we're going to need to do some graphing, so I'm going to hit my y equals. To graph these out, remember, we pretend there's an equal sign in there, so that won't really matter. Our first inequality was that y is greater than or equal to negative 4x plus 180, so we're going to have negative 4x plus 180. For our second one, we're going to have y equals negative x plus 90. And for our last one, we had negative 2x plus 160. Now, we will have to adjust our window. For my x min and x max, I'm going to go 0 to 100. For my y min and y max, I'm going to go 0 to 200, and I'm going to graph this out. So here's our 3 lines that we're dealing with. As far as the overlap, it would be this triangular region in the middle here. Now, we're going to focus on the intersection point. So I'm going to find this top intersection point up here. So when I go second calc and do option number 5, I'm looking at the intersection between my black line and my blue line. So for my y1, that's my blue line. That's my y equals 4x plus 180. So I hit enter. I want my black line, so I'm going to hit down so that it changes to my y3. So that's the negative 2x plus 160. So I'm looking for where that black line and that blue line intersect. So that's the point 10 and 140. Now we've got other intersection points that we need to find. So I'm going to go second calc and option number 5 again. For the next one, I'm going to look at the intersection between my red line and my black line. So I'm going to hit down to go to my red line and hit enter. Then I jump down to my black line. I hit enter, enter. So those 2 lines intersect at 70, 20. And then I need to do the intersection between my blue line and my red line. So second trace, option number 5. I'm on my blue line, that y1, so I hit enter. I switch over to my red line, that y2, so I hit enter, enter. And those 2 lines intersect at the point 30, 60. So now that we know our intersection points, we're going to go back to our objective function, which was our cost function. So that c equals 10x plus 5y. And what we're going to do is we're going to take those ordered pairs from the intersection points and we're going to have to plug them in. So our first intersection point was at 10 and 140. So I'm going to take those x's and y's and plug them in. So we're going to get c equals 10 times 10 plus 5 times 140. Now when we multiply and add, we should end up getting 800 as our answer. Our second intersection point was at 70, 20. So I'm going to take those and plug them in. So C equals 10 times 70 plus 5 times 20. And we're going to end up getting 800 there. And then our last intersection point was at 30, 60. So we get C equals 10 times 30 plus 5 times 60. Now when we multiply and add those together, we're going to get 600. Now our goal in here was to minimize our cost. So at that first ordered pair, we had a cost of $800. At our second ordered pair, our cost was $800. But at our third ordered pair, that cost was only $600. So if we're trying to minimize our cost, the lowest out of those three is that $600. So we're looking at that ordered pair 30, 60. Now remember, X was the bags of brand A. So we need 30 bags of brand A. And our Y value was the bags of brand B. So we should get 60 bags of brand B. That's going to be it for this video. Thanks for watching.